In the seventh grade, they were studying pi. It was a Greek letter that looked like the architecture at Stonehenge in England. Two vertical pillars with a crossbar atop. Pi. If you measured the circumference of a circle and divided it by the diameter of the circle, that was pi. At home, Ellie took the top of a mayonnaise jar, wrapped a string around it, straightened the string out, and with a ruler measured the circle's circumference. She did the same with the diameter, and by long division divided one number by the other. She got 3.21. That seemed simple enough. The next day, the teacher, Mr. Weisbrod, said that pi was about 22 over 7, about 3.1416. But actually, if you wanted to be exact, it was a decimal that went on and on forever without repeating the pattern of numbers. Forever, Ellie thought. She raised her hand. It was the beginning of the school year, and she had not asked any questions in this class. How could anybody know that decimals go on forever? It's just the way it is, the teacher said with some asperity. But why? How do you know? How can you count decimals forever? Miss Arroway, he was consulting his class list. This is a stupid question. You're wasting the class's time. No one had ever called Ellie stupid before. After school, she bicycled to the library at the nearby college to look through books on mathematics. As nearly as she could figure out from what she read, her question wasn't all that stupid. According to the Bible, the ancient Hebrews had apparently thought that pi was exactly equal to 3. The Greeks and the Romans, who knew lots of things about mathematics, had no idea that the digits in pi went on forever without repeating. It was a fact that had been discovered only about 250 years ago. How was she expected to know if she couldn't ask questions? But Mr. Weisbrod had been right about the first few digits. Pi wasn't 3.21. Maybe the mayonnaise lid had been a little squashed, not a perfect circle, or maybe she'd been sloppy in measuring the string. Even if she'd been much more careful, though, they couldn't expect her to measure an infinite amount of decimals. There was another possibility, though. You could actually calculate pi as accurately as you wanted if you knew something called calculus. You could prove formulas for pi that would let you calculate it to as many decimals as you had time for. The book listed formulas for pi divided by 4. Some of them she couldn't understand at all, but there were some that dazzled her. Pi divided by 4, the book said, was the same as 1 minus 1/3 plus 1/5 minus 1/7, those fractions continuing on forever. She tried to work it out, adding and subtracting the fractions alternately, sometimes bigger than pi over 4, sometimes less, but after a while you could see this series of numbers was on the beeline for the right answer. You can never get there exactly, but you could get as close as you wanted if you were really patient. It seemed to her a miracle that the shape of every circle in the world was connected with this series of fractions. How could circles know about fractions? She was determined to learn calculus. The book said something else. Pi was called a transcendental number. There was no equation with ordinary numbers in it that could give you pi unless it was infinitely long. And pi wasn't the only transcendental number. In fact, there was an infinity of transcendental numbers. More than that, there was infinitely more transcendental numbers than ordinary numbers, even though pi was the only one she had ever heard of. In more ways than one, pi was tied to infinity. She had caught a glimpse of something majestic. Hiding between all the ordinary numbers was an infinity of transcendental numbers whose presence you could never have guessed unless you looked deeply into mathematics. And sometimes they just pop up unexpectedly in everyday life. They were hiding, minding their own business, almost certainly unglimpsed by the irritable Mr. Weisbrod.